5.7, identifying types of symmetry on the Cartesian plane. So your goal for today is to demonstrate an understanding of line symmetry and rotational symmetry. So a diagram of a shape and its transformation image may have line symmetry, rotational symmetry, both line symmetry and rotational symmetry, or no symmetry at all. Okay, so we're just taking the same concepts that we've previously discussed, so line symmetry and rotational symmetry, and applying it on a Cartesian plane. So here's an example. Are the rectangles ABCD and EFGH related by symmetry? So we're going to look at the two objects and we're going to check for line symmetry and rotational. So if we look at line symmetry first, we're going to see that the rectangle ABCD is to the left of EFGH. So I'm going to try a vertical line of reflection. If I were to flip this shape over this line, I can see that E is one away, B is one away, H is one away, C is one away, F 1, 2, 3, 4, 5, 6 away, and A 1, 2, 3, 4, 5, 6 away. So the sides that are supposed to be proportional are matching each other in length. If I flip it, it will land on each other. So I can say that they are related by line symmetry. Okay. I'm also going to look at the same objects and see if there is rotational symmetry. So again, because they are separate shapes side by side, I'm going to look at a point of rotation between the two objects. So if I were to actually trace these objects and spin it around this point, you guys can picture that when it turns 180 degrees, it's going to line up. So sometimes you have to try different points to see if it's going to actually match up. And when you rotate it, you could see that the A is going to match up with the G and then back when it returns to the A. So we say that there is rotational symmetry. The order would have been 2, the angle 180 degrees. So here's a couple questions for you guys to try. If you have any questions, make sure you're sending me a message. If you want to pause this and go and work on it on your own and then come back, feel free to do so. If you would like to just go through it with me, you can do that as well. So for each diagram, find out if the polygons are related by symmetry. So first question is, do the polygons face opposite ways? Yes, so they are opposite. So the little two boxes on the top and down here, it's on the bottom. So because one polygon is above the other, I am going to try a horizontal line of reflection because I'm going to draw a line in between them, and it wouldn't make sense to do a vertical one. Okay, so I'm going to draw a line in between them. Okay, so you guys do not have a mirror, so you're just using the system. If it's one away on one side, it should be one away on the other. 2 away, 2 away. So you're just using your reflection skills. So are the polygons related by a reflection? Yes, they are. If they are, draw the line. That is the line that they would be flipped over. Second part is to see if they are related by rotational symmetry. So are the polygons touching each other? No. So that means I need to try a point of rotation between the polygons. Okay, so if I were to pick over here and turn it and spin, would it actually match up? Okay, maybe it's in the center. So you may have to get out a piece of blank paper and trace and turn and spin. You may be someone that's able to see it. If I put a point in the middle and I were to spin it around that point, okay, it would actually end up matching up. So do the polygons ever match? Yes. So are they polygons related by rotation? Yes, they are. And if they are, label the point. So I would have this point and I would put a P to show it. Second question, do the polygons face different ways? So yes, they are facing different ways, but are they facing opposite ways? And the answer to that is no. So because they are not opposite of each other, I can say that there is no lines of reflection because they would not match. Second thing to look at is the rotational symmetry. Do the polygons touch? No, they are not touching each other. So you're not finding a point on them. I'm going to find a point of rotation, try a point of rotation outside the polygons. Okay, so it wouldn't make sense to try and turn it around this point because it's never going to match up because this one is not touching that point. So I'm going to need to pick a point outside of the polygons. Okay, so this one a little bit more difficult potentially for you to see. If I were to like take this shape and trace it and put a point like over here, okay, and spin it anyway, you can see that it's not going to match up on that point. Maybe I'm going to try a point in between the two objects. So if I put it over there, is it going to match up? So sometimes for something like this, you got to try a couple different times before you can find where it actually fits. So that's a little bit over to the side. So if I move it over, now that's a little bit too low. Okay, so I might have to go in between them. And if I go in between them, I can see that it does actually match there. Okay, so sometimes your point of reflection is going to be in an odd spot and not perfect. So it is a lot easier if you have trace paper. If not, if you have white paper that you can just kind of like write softly on and spin and turn, it should be enough to help you out. Or if you're a visual person, you may be able to visualize it. So do the polygons ever match? Yes, they do. They are related by rotational symmetry, and you should always be labeling your point of rotation so that we know what it is. So there are some practice questions for you guys to be working on in your textbook on page 373. Try your best with the materials that you guys have at home. I understand it might not necessarily be that easy to do some of the rotations without the trace paper. And if you're really stuck on something, make sure you're sending me an email and I can help you out as best as I can. I look forward to seeing you again in class.